from this axis inclined to HP and axis inclined to VP category only mostly you will be getting problems in your exam, right? So you see axis inclined only to HP and the same axis is parallel to VP. So this is the condition, you know. You see here, the axis of the solid is inclined to horizontal plane and it is parallel to vertical plane, right? So in this orientation, the axis is neither perpendicular to HP nor to VP, right? It is also not perpendicular to axillary vertical plane also, right? So what we have to do? We have to, wherever the axis is inclined, I have to make it perpendicular to that. So now the axis is perpendicular to HP. I can draw a simple four positions, front view and top view. Okay. The base, since it is the axis is perpendicular to HP, the base will be seen in the top view. So top view I can draw it, front view I can proceed it. Then in the second step, the front view will be tilted to the given inclination. Then we will be obtaining the final top view, right? So this in two steps will be solving this kind of problem, right? Here you see axis inclined to HP. So what I have to do is I assume axis perpendicular to HP. First of all, I assume the axis is perpendicular to HP, then I can draw the base. Since the axis is perpendicular to HP, the base, true shape of the base is obtained on the HP, that is on top view, right? I can draw the true shape and proceed for the front, right? Then, in this axis inclination problem, okay, to draw the final projection, I have two procedures, methods, more. I have change of position method. One is change of position method. Change of position method. Change of reference line method. Change of reference line method. Change of position and change of reference line method. So this change of reference line method is also known as axillary projection method, right? Axillary projection method. I have two methods. So mostly we will be using in projection of solid change of the first method, change of position method. What is change of axillary method I will tell. Then we will be extensively using in section of solids. Right. So here we will use a hexagonal prism. It is a hexagonal prism. So given solid, neatly you write it, you will be making the mistake in the solid itself. Right, as I told earlier, okay, write it, it is a hexagonal prism, not pyramid, and it is hexagon of side, base side 30 mm and height 70 mm. 70 mm is resting on the ground. Ground means resting on HP. Okay, so resting on the ground, resting on HP, resting on the ground with one of its base edges, resting on edge. So it is resting on edge ground, one of its base edges, resting on edge. So resting on one of its base edges in such a way that the axis is 30 degree inclined to HP. Axis theta is 30 degree inclined to HP. Okay, axis is inclined to HP. Axis inclined to HP, that is 30 degree. Right. Axis inclined to 30 degree to HP and parallel to VP. You see, the axis is only inclined to HP, okay, and it is parallel to VP. It is not inclined to both. Okay, you don't have in your syllabus inclined to both planes. Okay, you have only in your syllabus inclined to only one plane, either HP or either VP. Right. The other plane it will be parallel. For the other plane, the axis will be parallel. Right. So axis inclined to HP, that is 30 degree. So full stop. Draw the front view and top view of the prism. Draw the front view and top view of the prism. Right. You are asked to draw the front view and top view. See here, this resting, this is something like this. You take this tool as a horizontal plane, take this tool as a horizontal plane, it is resting on the ground, that is on HP like this. So I have base edges, okay, I have base corners, okay, it is resting on what? Resting on base edge. So one of the base edge is resting on the ground and the axis is 30 degree inclined to HP. So it can be inclined like this. So another condition is given. What is that? The axis is inclined to HP as well as the axis is parallel to it. It should be like this only. Right. The front view, you know how will be the front view and how will be the top view, you have to draw it. As it is straight away, I cannot draw it the front view and top view. Right. So I have to proceed with two steps. The first step is the axis is inclined to HP. So I am making it to perpendicular to HP. This is a simple position. Right, this is a simple position. Now I can clearly draw the base, true shape of the base on HP and I can draw the front view. Right, then I can tilt the front view to 30 degree inclination. So what I am going to do, right. Now you can draw the true shape of the hexagon on HP. So wherever it is resting, or wherever the axis is inclined, there the you have to draw the true shape. Now the axis is inclined to HP, so you have to draw the base on HP. Remember that. Since the axis is inclined to HP, you draw the base on HP. Right. So if the axis is inclined to VP, you have to draw it. Now I can draw the hexagon in two orientation. You see, like this, I can draw the hexagon, true shape of the hexagon. Is it right or this one is right? So which one is right? You have to be careful. Which one is right? Second one. Why? Second one. So you see here, first step. For the first step, I will be projecting the front view like this. Right. So I am going to tilt the front view, change the position of the front view to 30 degree. That is the change of position. So if I tilt, so whatever falls here, is it edge or corner? Whatever projection I have in this front view in this location, what is that? It is nothing but the edge. Okay, this edge I will have here. Say suppose it is CD. The CD edge I will have here. Suppose I tilt this front view, change its position and tilt this front view. I have to keep the edge here at CD. CD edge has to be on the ground. Suppose I tilt like this, you see the edge has to rest. Okay. So now you tell which one is right. If I project this case, whatever I will have in the projection front view. In the extreme I have corner. So I will have corner in my front view. So while tilting, a corner will be resting on the ground. Is it clear? So in plane problem itself I have given this. As for hexagon concern, okay, if it is resting with the edge, you keep the hexagon, you draw the true shape of the hexagon in such a way that edges in the extreme. So here I have the edges in the extreme. In the extreme I have edge. Here you see what I have on the extreme. What I have corner. If it is resting with the edge, you keep as you draw the hexagon such that the edges will be in the extremes. Okay. If it is resting with the corner, you draw the hexagon such that you keep the corners in the extreme. Okay. Having the corners in the extreme. Is it clear? So now since the problem it is resting with that base edge, so So I have edge in my extreme. If it is a pentagon, no problem. I have in my extreme edge I will have, a corner I will have. If it is a pentagon, I will have my edge in the extreme. On the same way, I have a corner also in the extreme. Okay, this is the only orientation for hexagon, pentagon. I have two orientation for hexagon. So this is for if it is resting with an edge. This is for if it is resting with a corner. If it is resting with the edge, resting on edge. So I have to draw it like this. If it is resting on corner, I have to draw it like this. Right? Clear, you should not make mistake in this. Now this problem is resting with an edge. So I have to draw it like this. So you draw the confused. This is a simple position I am drawing. It is resting on HP like this, right? And I am assuming that it is perpendicular to HP. If it is perpendicular to HP, the true shape of the base will be on the HP. Okay. So I have to draw the true shape on HP like this, right? So this is the hexagon I have drawn. So both the bases will coincide here. So you can give the notations starting from the left. Extreme bottom corner, right? A, B, E, F. Similarly, I will have another base. Okay, I can name it in numbers. Okay, 1. So both these get points right here. Now I can go for my simple projection. For this, what is the simple projection you will have? Just I can project it. What I told, for simple position, you mark the center, from the center, axis line, axis projector you draw it. Okay, one base will be on the reference line, another base for the will be 70 mm apart from the reference line, right? That is nothing but the height. So I am projecting here, right, from the axis line, you can measure 70 mm. Can project front view, this is my projection of simple position, perpendicular position, right? So I can give the notation. So this side is this height is right. Then if notations, I can have any one of the base. Okay, for your to your convenience. Okay, this is A dash, C dash, this is D dash. That, right. Then I will have right. Now you can show the hidden corners. Okay, as it is simple question. Hidden corner. So as for the top view, which base is hidden? As for the top view, which base is hidden? You look at the front view from the top. Okay, to mark the hidden details for the top, you look at the front view from the top. ABCD base is hidden. So I have to put it in bracket. Right. Then as for front view concerned, you look at the top view from the bottom, which will be hidden. These three edges, vertical edges will be visible. These three vertical edges will be hidden. That is F, 6, 5, 4, F, E, D. Right. So this is the simple question you have drawn. This should be drawn in 2H pencil. It is a light one. This is not the final front view and final top view. Now, in the second step, you are going to draw the final front view and final top view. That you have to darken it. You see here in the second step. So I have to tilt the front view, final front view to 30 degree inclination. Okay, the axis is 30 degree inclined. So listen, axis is 30 degree inclined. What you can do, just which is going to be my resting corner. If you tilt, listen, if I tilt, so you see here in this orientation, this is the base, ABCD base in the bottom, which is on the stool, right? So if 1, 2, 3 base is on the top, if I tilt it, okay, so ABCD base, the edge will be on the ground. What is that edge here? CD. CD is the edge going to rest on the ground. So I can mark that CD edge on the ground. Right. This is going to be my C dash D dash. Right. That is an edge. If it is a resting with a corner, a single notation you will get here. Right. This is CD is nothing but an edge. CD is nothing but an edge. So it is resting with an edge CD. Now the axis is inclined. Okay, for your easiness in projection of pyramids also, what you can do, the axis inclination, you measure it for the base, you convert it as a base inclination. So what is the axis inclination here? It is 30 degree. So if I tilt this solid to 30 degree, axis 30 degree inclined to HP. What about the inclination of the base to HP? You see, I'm going to tilt this axis. Okay, the solid is going to be like this. Just so you see here the axis, I'm going to tilt it to 30 degree. Right, the axis I'm going to tilt this to 30 degree. So if this is 30 degree, so you consider this motion only. If this is 30 degree, what about the base inclination here? 60. Okay. So 90 minus 4. This is perpendicular. This will be 60 degree. So if the axis is 30 degree inclined, you use the base inclination as 60 degree. So what? It will be used. Is it clear? So axis is 30 degree. You convert it to base inclination. So what I'm going to do? I'm using the base inclination as 60 degree. Just what I'm doing here. Just I'm reproducing the front view in a tilted manner. I'm reproducing this front view, okay, redrawing the front view in a tilted 30 degree orientation. Okay. So for this, the axis inclination I know 30 degree. I'm converting it to the back base inclination. If the axis is 30 degree inclined, the base will be 60 degree inclined. So I have marked the resting edge. So just you draw a 60 degree line. Draw a 60 degree line. Draw a 60 degree line. So this line is 60 degrees. So say this is 60 degrees. You don't need to dimension. Right. So along this, what I have to mark it, I have to keep my base ABCD. So CD is here. So I can measure C to B distance. Okay. That I can transfer it here. I can measure C to B distance. That I can transfer it. Right. So this is my locations of BE and AL. Right. Just to measure it and transfer it. This is my B dash, E dash. This is my A dash, F dash. Is it clear? Just I have transferred the base to 60 degree inclination. So this is what you have to do it. The axis inclination will be given, that you convert it to base inclination, that is 60 degree. Mark the resting edge or resting corner on the reference line. You redraw the base, okay, to that 60 degree inclination. Now I can redraw this. How I can draw this? Just you can redraw this. From here I can draw a perpendicular line to this up for 70. So similarly already for 70 I can draw 70, right? So I can draw 70. You draft the front view. After this, right? So this is C dash. C dash. Here I have Right. Now you see this axis. Now you can show the axis here in the middle. The axis is you can represent it like that. You can extend it outside, you can represent it. See here, now the axis is inclined to what degree? So that you have to dimension it. The axis I can, it is 30 degree inclined. The axis is 30 degree inclined here. The axis here is 30 degree inclined. So for the axis 30 degree incline, I have measured 60 degree of the base, then I have redrawn it, reproduced this front view. This is nothing but the change of position. Right. So now to proceed for the top view, what I have to do is similar to your projection of planes, you project all the base corners from the front view and you project all the base corners from the previous top view. You will get the intersection location. Where is intersection location? You mark, you get the intersection location. Just I am projecting. So you can ask, why sir you have measured 60 degree for the base, 30 degree axis this here, the side itself it is 30 degree, going to be 30 degree. As for prism it is okay. If it is a pyramid, you will be struggling. Right. Prism, I can measure 30 degree, I can mark CD, I can measure 30 degree and I can measure 70 mm. I can mark 3, 4 and I can proceed it. I can reproduce it. Okay, so you can do that. Right. But pyramid, it will be difficult, so you have to convert that. So you follow this 60, you convert that to base inclination, then you proceed it. Then extend this previous. See here. Now the intersection locations you mark. So this is my point, intersection point A. Right. So I have got a intersection point. Now, your task, listen, your task is to I have got in the top here I have got the corner locations, right? Now listen all of you, listen. This is important, you will be making mistake in this only. Up to this it is simple. Solid is simple, you see. The hidden details, which is going to be hidden, which is going to be visible. So it is in a tilted manner like this. Okay, you cannot see whatever I am seeing from the top view. From the top view I am going to draw. So what I am going to do, you see, you have your this board as horizontal plane. Consider board as horizontal plane. It is like this. You are looking at the top view. It is not front view. Okay, you are looking at the top view. Right. So what you are saying? Can you see this base? Yes. This base is visible. This base is hidden. Okay, not visible. Similarly, same condition, I can see this base. So this base is fully visible for me. From my viewpoint, this base nearest to my viewpoint, this base is visible, fully visible. This base is not visible for me. It is partially visible. The base, 3 of the base are visible, the other 3 is not visible. So what you can do, first of all you can draw the base. So before that, what you can do in the top, any view you see, the boundary of the view will be fully visible. So what you can do is, the boundary in the sense, outline, okay, overall outline of the view, boundary of the view is fully visible. Definitely it will be visible only for any view. So what is the boundary here? A to B, B to 2, 3, 4, 5, E, F. That is going to be my boundary of this view. What is this boundary of this view? This. Right. Similarly, the boundary is fully visible. So I can connect all my boundaries. Okay, that is the thing. Okay, this is a rough one. What you can see, as for this condition, which is the fully visible base, first of all you can join it as a fully visible one, which is the partially visible base, we can join it, right? The another one, so which is, what are all the hidden edges? Okay, hidden side edges. I have side edges, 6 side edges as far this prism concerned. Okay, what are the side edges going to be hidden for me? You have to visualize it and you have to draw it. Okay, I will give you a hint. Okay, to follow that hint, it will be very useful for you, right? So if you are able to visualize and you are drawing, it is well and good. So if you are not able to visualize and you are not able to properly put the hidden lines and visible lines, you follow the hint what I am giving. So just make a note of any view is fully visible. Boundary of any view is visible. Right. So boundary is visible. So what I can do is the boundary, whole boundary is visible. Just I can connect, join all the boundaries as a visible one. So this is my boundary. Boundary of the view is fully visible. Right. Then see second hint that you can have it. The base, the nearest base from the viewpoint is visible, is fully visible. The nearest base from the viewpoint, the nearest base from the viewpoint is fully visible. Fully visible. Corresponding other base is partially visible. Right. So you see, to draw the top view, I have to look at from the top. Which is the nearest base? Which is the nearest base I have in both these bases? Number 1 or letter 1? Number 1 is fully visible. So this base is fully seen. So I can draw it as it's fully visible one. So I can draw it. This is a base. So that base corner I can draw it as a fully visible one. So already half portion in the boundary I have. I can draw it as a fully visible base. Right. So you see the corresponding other base. This is the corresponding other base is partially visible. Partially visible in the sense this half is visible. The top half of the from the axis, the top half is visible. Below the axis is hidden. So from the axis, the top half notations are AF, BE. So AF, BE. Okay, so already it is on the boundary, it is visible. The other half, BE, CD, that is BE, CD. Okay, that is hidden. It is partially visible base, so that is hidden. You have to join it with a hidden line. Right. So you see, one base is fully visible. That is the nearest base from the viewpoint, and the other base is partially visible. The partially visible portion is from the axis. Above the axis is visible. Below the axis is hidden. So that I have joined it with a hidden line. That is the corresponding other base is partially visible. That is hidden. So the corresponding other base is partially visible. Partially visible. Alright. Then you see, the bases are over. Now I have 6 side edges. So what are the side edges are hidden for me, that you have to look at. So see here from this one. So whatever I am seeing from the top, that side edges are visible for me. Whatever it is on the bottom, okay, that is hidden for me. The side edges, you know, the side vertical edges are nothing but the vertical edges of this prism. Okay, the 4 of the vertical edges of the prism in this tilted orientation is visible. two of the vertical edges are hidden, that is on the below the axis. So what you can do is, below the axis, whatever side edge you have, so below the axis, whatever side edge I have, CD and 3, 4. Okay, this is the axis I have. Vertical edge is nothing but C3, D4. C3 is a vertical edge, D4 is a vertical edge. See here. C3 is a vertical edge, D4 is a vertical edge. Right. Below the axis, C3 is a vertical edge, D4 is a vertical edge. So below the axis, that vertical edge is hidden. So you connect C3 and D4 as a dotted one, that is hidden. Right. So the remaining side edges are visible. So what you can do, you can have the side of slant edge, side of slant. So slant, listen, the side edge for prism. If it is a pyramid problem, you will have slant edges. Side of slant edges, edge below the reference line, below the axis is hidden. Right. Or I can have R. So this is a statement R. Similarly, side or slant edge, okay, side or slant edge. You see, this is hidden, you know, CD, C3 and D4. So that is the bottommost one, that is hidden. You can join it. Okay. Otherwise, you see another statement, whatever side or slant edge which is crossing the fully visible base. So I have a fully visible base, side or slant edge. So I have a side edge B2, it is not crossing the fully visible base. I have a side edge A1. A1 is not crossing, it is ending up to here. I have a side edge C3. C3 is crossing the fully visible base. If a side edge or slant edge crossing the fully visible base, that will be a hidden one. Right? Side or slant edge crossing the fully visible base. Fully visible base is hidden. Right, the same thing. So which side edge is crossing here? This is a fully visible base I have. C3 is crossing, D4 is I have. C3 is crossing, D4 is crossing. Same thing is hidden, right? So R, I can have another statement. Side or slant edge, side or slant edge from a hidden corner, hidden base corner, from a hidden base corner, is hidden. Right. So which is a hidden base corner here? Which is a hidden base corner here? Hidden base corner, you see, I have two base. So one of the base corner, CD is the base corner which is hidden for me. I can see B, I can see A, F, I can see 1, 6, 2, 5, 3, 4. I cannot see the corner C and D. So that is a hidden corner. You can identify it in such a way that which is a corner, it is of two dotted edges, base edges. This is a corner, it is of two dotted base edges. It is a point, intersection point of two dotted base edges. That is going to be a hidden corner. It is C is a corner, it is an intersection point of a two dotted base edges. Okay, so C and D is a corner, hidden corner. So from that corner, whatever side edge I am drawing, okay, that is going to be hidden. So you can follow any one of these three, depends upon the problem, premise, okay. If you are very well known to this, you can solve, you can show the hidden and visible edges neatly in your solids problem, right? So all these statements will give me the same one. C and 3 is going to be hidden. As for the first statement, this one, okay, that is below the axis I have CD, C3 and D4. After the second statement I have the slide edge which is crossing fully visible case, again it is C3 and D4. As per this statement, again the hidden corner is C and D. So from that hidden corner, whatever side edge I am drawing, that is hidden. So my hidden side edge, only hidden side edge is C3 and D4. Is it clear? Now, so I have already D2, I have C3, D4, E5 side edge I have. Two more side edge I have. What is that? B22 I have, C23 I have, D24 is hidden, E25 I have, then F2 6. That will be visible. Okay, so that will be visible. You see here, F2 6, I have to join it as a continuous one. So already I have a hidden portion there, that will be overlapped. Okay, so the visible one will be shown in your view. So if a hidden and visible edges are overlapping, visible edge will be shown. So you see here, similarly A to 1, I have inside here, A to 1 is visible. So up to this, so this portion alone, it is hidden, shown hidden, base here is hidden. Is it clear? Do you have any clarification in this? Follow this hint. Right, it will be useful for all your problems in solids. Right. So just with this is going to be your front view and this is going to be your top view. Finally, darken this. The axis inclination 30 degrees given. The dimensions you have to dimension it. Axis you have to show it. Okay. Right. This is the final front view and top view. Right. Is it clear? This is my change of position method. So change of reference line method you have. You see that you can avoid one more reproducing the front view. You can avoid that. You can have only 3 views. Okay. Within 3 views you can close from axillary projection method. Okay. The same problem. So I told you this is the one change of position method what we have seen. Just the front view you have changed this position to 30 degree incline to the horizontal plane. You have drawn the front view and top view. Right. Here, this is another method I told. It is a change of reference line method or axillary projection method. Change of reference line or axillary projection. In this, I can avoid one view, drawing one view, right? Redrawing this front view. I can keep this as a final front view. Right, what I am going to do, just I am changing the reference line to 30 degree. I know the edge, resting edge is CD, right? That I am just changing the reference line, touching the resting edge CD. What I am going to do, the reference line just I am tilting and I am redrawing the reference line here. Redrawing the reference line. This is the reference line, a new reference line I am drawing. So to what angle I have to draw it? To the axis, this reference line has to be 30 degree and the conditions also should be maintained. Which is going to be resting? CD is going to rest on the ground. So this is the reference line. CD has to rest on the reference line. So my reference line has to touch CD and I have to change the reference line in orientation 30 degree incline to the axis. Right. This is how I can keep it. Now, this is the axis. For this axis, this reference line is 30 degree incline. So this is my x, y. So which is going to be my final front view now? I haven't redrawn the front view changes. So this is going to be my final front view as it is. I can darken it. I can darken the final front view. Now I have to draw the final top view. So final top view will be, all the corners should be perpendicularly, it should be projected to the new reference line. So I can draw a projectile perpendicular to the new reference line. See here. So I have extended the projectile perpendicular to the new reference line. Right. This is how I have to extend it. Right. Now, how to get the final top view? At the top. So what I have to do? The corners of the previous top view from the old reference line. From the old reference line. This is the old reference line I have. Okay. Old reference line. From the previous reference line, what is the distance of these corners? Okay, top view corners, what is the distance? From old reference line to 1, what is the distance? That I have to measure it. And you have to transfer it on a corresponding projectile line from the new reference line. So, this is for A1. So, from A, what is the projectile line I have drawn? Okay, that along that, okay, this distance has to be transferred from the new reference line. So this is going to be my what? A. Right. So A projectile line. So what is the distance from the previous reference line to corner A? That you have to measure it and you have to transfer it to the from the new reference line along the projectile line A. Right. So similarly, all the corners has to be transferred. So A1, the same distance A1 I have, I can transfer it from 1 from the new reference line. I can transfer it here. This is going to be 1. So A6 and F. From this distance I can transfer 6 and F. Right. Then this B and C. So B of 6. B and 6. This is F1, B and 2. Similarly, I will have 2, 3, 4, 5, C, D, and E. Is it clear? This is how I will be getting my final. Here, you have to look at from this direction. This is the top view direction, perpendicular to the new reference line. So which is the fully visible base? This one. This fully visible base will be connected with a continuous line. The partially visible base is this. So this portion is invisible, hidden. Right. Then I have to connect the side edges, which is the bottommost edge to the new reference line is 3, 4 and CD. That I can join it as a dotted line. Right. The other edges will be fully visible. This is how I will have my projection. So in this change of reference line method, just reference line will be redrawn to the tilted angle axis inclination and to the exact position, right? And the front view, what you have got in the simple orientation, that will be used as a final front view, right? And the top view will be obtained like this. This procedure we will be using in section of solids. We will see that in detail, right? So you know the procedure, so we will avoid one view here. Right. So we will follow the change of position method for projection of solid control. Is it clear? Right. Once again we will deal it in section of solids. Take the next problem. The pentagonal pyramid. Take it as a pentagonal pyramid. Pentagonal pyramid. The pentagonal pyramid of base side. Pentagonal pyramid of base side. Base side 30 mm and height 70 mm. is resting on ground with one of its base corners, is resting on ground with one of its base corners resting on HP, resting on a corner in such a way that the base is 50 degree inclined to HP. The base is 50 degree inclined to HP and perpendicular to VP. Base is 50 degree inclined to HP and perpendicular to VP. Full stop. Draw the top view of the prism. Base inclined to HP 50 degree. Right. So see here the axis inclination is not given. You have an axis inclination in this problem. So hereafter we are going to see the problem. The axis is not directly, the axis is inclined to HP, inclined to VP. The direct inclination of the axis with the reference plane is not given. So here it is given. The base of the pyramid is inclined 50 degree to HP. So then if the base is inclined to 50 degree to HP, you see here. So it is considered as a hexagonal, pentagonal pyramid. It is resting with a what? Resting with a corner on HP, right? It is resting on HP. It is resting with a corner, and you see this base. This base is inclined 50 degree. So the base is inclined 50 degree. Then correspondingly, if the base is inclined 50 degree, corresponding the axis also inclined to HP. If the base is inclined to HP, the axis also will be inclined to HP. You see here in this orientation, the base is inclined to HP. The axis also it is inclined to HP. The previous problem, the axis inclination was given. You have used it as, converted that as base inclination, you have used it. Directly the base inclination is given. So you see here, this orientation also, the base is inclined. The base is inclined to 50 degree to HP. Now one more condition is given. The base is inclined 50 degree to HP. Also it is perpendicular to VP. If this is the orientation, then how about the base? Is it perpendicular to VP? No. It is inclined. Somewhat it is inclined. The base inclined to VP. So if I keep it like this, in this orientation, the base will be perpendicular to VP. Right? That means the axis is what? Parallel to VP. So both the details is hidden in this problem. So the axis inclination is hidden. Instead of axis inclination, base is inclined to 50 degree is given to HP. Instead of axis parallel to VP, the base is perpendicular to VP, it is given. Now this problem also it falls in this category. Axis is inclined to HP and parallel to VP. So I can say in this problem also the axis is inclined to HP is hidden. Inclined to HP and parallel to VP. Why? So axis is inclined to HP and parallel to VP. Now where I have to draw the base of the pentagon on HP or VP? HP. Why it is HP? It is inclined to HP. So since the axis is inclined to HP, so I can draw the base on HP. So you draw the reference line neatly. You can draw the base on the HP. The axis is inclined to HP, you can draw the base on. So Pentagon you know. So you have only one orientation. Right, Pentagon. See here. Listen. Since the axis is inclined to HP, okay, I have to draw the base on HP. Right, I have drawn the base here. You have, as for Pentagon, I have only this orientation. In the extremes, I have what? A corner I have and edge I have. Right. Even though if it is resting with the edge, resting with corner, you can draw it in this orientation. Right. Now it is a pyramid. Since it is a pyramid, I can see the side edges also. I have to connect, I have to mark the apex in the middle. You mark the center of the pentagon, you mark the apex and you draw the, show the side edges also. There is slant edges. Right. Mark the center. Then how I have to proceed? You project the axis projector line. Okay, you draw the axis projector line. So along the axis projector line from the base you mark the apex. Along the axis projector line from the base you mark the apex to the height of the pyramid. It is 70. See here, I have drawn this simple position, okay, from positional front view and top view, right, front view and top view. So, from the top view, draw the axis line, mark the apex, then you project all the base corners to the front view, then you join all the base corners to the apex, that is the visible slant edges, you join it, right. Then this is the height is given 70. Now see here, by change of position method I have to now change this front view to the tilted orientation, that is the base is inclined 50 degree to HP. So it is resting with a corner like this. Okay, it is resting with a corner like this. Just I can tilt it. So the base I can tilt. Now which one is the resting corner here? Which is going to be the resting corner? I have C. Okay, C is the resting corner I have. That C I can mark it on the reference line. So C dash is going to be touch the reference line. Okay, it is resting with a corner on the reference line. If the same problem it is resting with an edge, which one I have to mark it here? Which one I have to mark it here on the reference line? AE. Okay, AE I have to mark it on the reference line. Since it is resting with a corner, I have to mark the C dash here. Now I can draw a 50-degree inclined line to the reference line. So 50-degree inclined line. Right. This base is inclined 50 degrees. Measure the locations of the base corners. So C dash to D dash, B dash, okay, that is nothing but this location. Okay, I can measure it and I can mark it. So these are all the locations of the base corners. Now this is my base. Now what I can do? How I can redraw this front view? How I can mark this apex? How I can mark the apex? So I have these two extremes. Okay, two extremes I have. From these two extremes of the base, what is the distance to the apex? I can measure it. I can get an intersection of the apex, or I can mark the base location of the axis. Okay, axis wherever intersects the base, from the base, that I can mark it exactly. Okay, on that I can draw perpendicular to the base. I can draw an axis line. I can draw an axis line. So this axis location is different from the base corner location. Okay, DB base corner location is different, axis location is different. So from the base, whatever the distance, the apex is, the height of the solid, that 70 you mark it. This is going to be my apex. O. That. Right. Then I can redraw because this slant edges also. Once you have redrawn this front view, you can proceed for the final top view. Just extend the project. Right. Now, see here. Follow the head, okay, whichever is it the base. Look at the front view, the base, whether is it fully visible or partially visible. Base, looking from the front view from the top, okay, the base is fully visible or partially visible? Partially visible, okay. So the apex is nearest, okay, that is visible. The partially visible base portion is below the axis, whatever base that is hidden, so above the axis is visible. So up to this AE and DB, okay, the top half is visible. So So this AEDB, okay, that is fully visible. So that portion I can connect it as a continuous line. That edges are fully visible, right? The other remaining portion, DB and C, it is hidden, it is partial, so I can join it as a dotted line. Right, as per the hint you can see, so it is a partially visible base, it is not a fully visible base. I have only one base, it is a partially visible. I have to join, I have to draw 5 slant edges, okay, so I have to draw 5 slant edges. So in that, which one is going to be a hidden slant edge? Which one is going to be a hidden slant edge? What is the hint is given? Which is the C dash? Which is the bottommost, okay, below the axle, whatever slant edge I have, that is C dash and O dash, that is a hidden slant edge I have. C and O, it is going to be a hidden one. The same thing, another hint gives, whatever corner is, whatever slant edge drawn from a hidden corner, slant edge or side edge, which is a hidden corner here. C is a hidden base corner. C is a hidden base corner. C to O is going to be a hidden slant edge. So that I can join it as a hidden line. Right. Remaining slant edges will be a continuous one. That is B to O. Continuous one. A to O. Right. All these corners are, slant edges are visible. A pentagonal pyramid, of base side 30 mm and axis side 70 mm, same thing, is resting on HP with one of its base, resting on HP with one of its base edges. Resting on HP with one of its base edges. Instead of corner, base edge. Base edges. In such a way that base corners on HP, full stop, okay. Draw the projections of the pyramid, draw the projections of the pyramid. Draw the projections of the pyramid. If the base is tilted in such a way that, if the base is tilted in such a way that the extreme base corner, the extreme base mm above the ground. The extreme base corner is 25 mm above the ground. Right. So what is the question is given the same. It is a pentagonal pyramid. It is a pentagonal pyramid. It is resting with what? Resting with an edge. It is resting on where? HP. HP. You see here, the same thing. It is resting with an edge. You see here, it is resting with an edge such that the resting edge is perpendicular to VP. The resting edge is perpendicular to VP. You add it. The resting edge is perpendicular to VP. Right. Resting edge is perpendicular to VP. Is it clear? So here also the axis inclination is not directly given. The axis inclined to HP data is not directly given. Instead of that, what is given? It is resting with the edge on HP and the resting edge is perpendicular to VP. If the resting edge is perpendicular to VP in the sense what? The axis, how it is to VP? The axis should be parallel to VP. So the axis is parallel to VP. And the other extreme, it is a pentagon, it is resting with the edge. A corner, the other corner will be opposite to that. Okay, that corner, that is the extreme other corner, is that corner height is given from the ground. That corner height is 25 mm above. If that corner is 25 mm above the ground, then how the solid is tilted? The solid is tilted to, the axis of the solid is tilted to, inclined to HP. Okay, the axis of the solid will be inclined to HP, should be inclined to HP. Since the resting edge is perpendicular to VP, the axis is parallel to VP. Right. Since the another corner of the base is tilted such that, the extreme corner of the base is tilted such that the corner is 25 mm above the ground, then the base will be inclined. Now the base will be inclined. The axis also will be inclined to the HP also. So here, this category also, it falls axis inclined to HP problem. So since the axis is inclined to HP, I can draw the pentagonal base on HP. Right. Then I can proceed for the simple position. This is the simple position, the same simple position you will be having. What is the tilted position here? What will be the tilted position here? Which one I have to keep it? The same thing, you see here, which one I have to keep it? This is the previous problem. Okay, the same simple position you will be having. So which one now I have to keep it on the reference line? Either corner or edge. It is resting with what? It is resting with edge. So since it is resting with edge, what is the edge here? I have edge notation AE. So AE I have to mark it on the reference line. AE, right, A dash, B dash. Then the other opposite corner is C. Okay, that C is 25 mm above the ground. So what I can draw a 25 mm locus line. 25 mm locus line from the reference line. This is nothing but my above distance of that extreme corner. This is 25. Right. Now what I can do is, I can measure this length of the base in the front view, that is A to C distance. That distance I can measure it in my compass. From A to E, I can cut it to the locus. Okay. A to E, I can cut it to the locus. So this is going to be my C dash. Now is it clear? So A to E, A to C distance of the front view. Okay. That will be marked on the locus. C is marked on the locus. Right. Now this joining there will give me is nothing but my base. Now is it clear for you? Instead of axis inclination, I can have a base inclination. Instead of axis inclination, I can have a above distance of an extreme, another extreme, right, of the base. So if this extreme is given, I can mark the base or corner here. The base distance I can measure it in my simple position view, front view, and I can cut it to that locus. I will get that another corner. Now what I can do is, just like that you can redraw it to this orientation. Okay, the same front view can be redrawn to this orientation. See here, the other location I can mark it. The axis location I can mark it. I can draw an axis line. So you can mark the apex. You can connect. So again you have to proceed for the top view. The same top view, that will be a different top view here. How it will be? So just by projecting this. what is the formula I have? There is AE. So A and E. D. This is going to be my apex. Okay, the base is partially visible. This is right. So the base is partially, the top half is visible. This is visible, and this portion is hidden. So what are the slant edges to be hidden here? What are the hidden corner here? It is A and E. The hidden corner is A and E. From the hidden corner, whatever slant edge I have to draw, that will be hidden one. So other corners, other slant edges are fully visible. Try this. Okay, the same simple question, you have to draw it as a separate diagram. The same simple question you draw it, then you tilt it, you redraw it, do this orientation, you draw the front view and top view. Okay, we'll continue to the projection of solids. Okay, listen. We are in the orientation axis inclined to HP and parallel to VP. Right. Take this next problem. In this category, right? Yeah. Hexagonal pyramid. A hexagonal pyramid. Hexagonal pyramid. Right. The solid, first of all, it is a hexagonal pyramid, not hexagonal prism. Right, it is a hexagonal pyramid of base side 30 mm, of base side 30 mm, and axis height 70 mm, is resting on HP, resting on HP with one of its base edges, resting on HP with one of its base edges, that is resting on edge here, one of its base edges. In such a way that the triangular slant face containing the resting base edge, triangular slant face containing the resting base edge is perpendicular to both HP and VP, is perpendicular to both HP and VP. First draw the elevation and plan of the pyramid. Draw the elevation and plan of this problem. See here, just I will explain. So here, you have any axis inclination is given in this? There is no axis inclination at all. Do you have any axis inclination here? Right. Then how to find out whether it is inclined to HP or inclined to VP? See the problem, it is given, it is resting with the base edge. You see I have a hexagonal pyramid, it is resting with the one of its base edge, such like this it is resting. Right. So it can rest like this in any orientation. But what is given another condition? A triangular slant face. You know, pyramid has, this hexagonal pyramid has 6 triangular slant face. So a triangular slant face containing the resting base edge. This is my resting base edge. Okay. Okay. that resting base edge, along that I will have a triangular slant face. That triangular slant face orientation is given. How it is? You consider that triangular slant face as a plane. That plane is both perpendicular to HP and VP. Is it right? No. Now only it is right. You see, this triangular slant face is a vertical one. It is, the plane is perpendicular to HP and it is perpendicular to VP. A plane, if you consider a plane if I keep it perpendicular to HP and perpendicular to VP, here the plane is nothing but the triangular face. The triangular face is like this. The triangular face on which it is resting along the base edge. So that is perpendicular to VP and perpendicular to HP. This is the orientation. Now in this orientation, you look at the solid axis, you look at the solid's axis, how it is? The solid's axis is inclined to which plane? HP. So in this problem also, it is a hidden data, it is given, it is that is nothing but the axis is inclined to HP. So in this orientation, the axis is inclined to HP. So you have to find out here, the axis is inclined to HP. It is a hidden one. Okay. It's not straight away, it is not given in your problem. Okay. Depending upon the orientation of that triangular face, that triangular face is perpendicular to both HP and VP. Right. So now it is inclined to HP problem. Right. And it is inclined, it is resting with an edge problem. Right. So it is a hexagon. So hexagon, you know, now since it is inclined to HP, where I have to draw the base, the true shape of the base on HP. Right. So the true shape of the base is drawn on HP. As for hexagon concerned, you have two orientation for the hexagon. So keeping the edges at the extreme, keeping the corners in the extreme. Since here it is resting with an edge, so I have to draw the hexagon such that the edges should be in the extreme. Right. So I can assume the first step, since it is an axis inclined problem, such that the axis is perpendicular to VP. So I can see the true shape of the base on axis is perpendicular to HP, such that I can see the true shape of the base on HP. You draw the simple position. You draw parallelly. You draw the simple position of the hexagonal pyramid here on HP. Since the axis is inclined to HP, I have drawn it here. The orientation you have to draw it like this, such that it is resting with the edge. You keep the edge to the extreme. Okay. The hexagon is drawn like this, such that the edges be to the two extremes. Right. Now, in the second step, I have to reproduce this front view, designer view. I have to redraw this front view, designer view. I have to redraw this front view. So, what is the condition is given? You see here, it is resting with the edge. Which is the resting edge here? Resting base edge here. CD, right? Which is a triangular slant face along that resting base edge. CD, O. Okay, CDO is a triangular base, triangular slant face in the top view. This is the triangular slant face I am talking about. Right. So this triangular slant face is seen in the front view as what? This triangular slant face is seen in the front view as a what? Here. The same notation you see, CDO. It is seen as a line, straight line. You see, the plane CDO is a plane, triangular plane. It is seen as a straight line here. So it is nothing but a plane perpendicular to both HP and VP. Now if a plane is perpendicular to both HP and VP, this CDO is, which is nothing but a triangular slant face, that has to be a vertical one. If I tilt it like this, you see, this CDO will be seen as a vertical line. That CDO in your simple position, I have a slant line. That line, you mark the CDO, that is nothing but the resting edge, C dash, D dash, right. Then you measure this CDO, what is the length? That has to be drawn as a vertical. Okay, that has to be drawn as a vertical line. So this is my apex. O dash. Right? So the orientation is nothing but the CDO, triangular slant faces perpendicular to both HP and VP. That same CDO, if I have a plane perpendicular to both HP and VP, how it will look in my front view and how it will look in my top view? The plane will be seen as a straight line in the front view as well as straight line in the top view. So that's what we are going to get in the top view also, right? That CDO will be seen as a straight line in the top view also. Now, you know, I have to measure the CDO and I have to draw it as a vertical line. Then how I can redraw this? How I can redraw this front view? And you don't need of angle. I know two destination locations. What I can do it? I know two destination end locations. So in this view, what is the distance for CD to A? What is the distance to C to A? That you measure it from C to A, you get an R. Okay, similarly, same distance O to A. What is the distance? There is nothing but this distance. Okay, this one. O to A, what is the distance? From O, you get an R. The intersection I will get, that is what? A. Right. Then B, you can mark it, it is exactly middle. That is B dash, B dash. Right. So just you have to have redrawn such that the CDO triangular face as a vertical one. Right. Then I have to redraw that. Now you can see the axis of the solid is inclined. It is inclined. The axis of the solid is inclined. Anyhow, it is inclined to HP. Right. Now, before that, give you the intended details. Right. Then you can proceed for your final top view. You can proceed for your final top view. Now you extend projectors from the final front view and previous top view, right? Listen, then you draw it. Listen all of you. See here, I have tilted the front view. I have not finished the final front view. Then I have extended projectors from the final front view and the previous top view. I have extended a horizontal projector. So both from that I can get the final top view points of all the corners. Okay, including the apex also. Right? I have got. Now you see. Whether while looking from the top, can I see the base fully? The base is fully visible or partially visible? Partially. Carefully you look at this solid, is it fully visible or partially visible? You see this one, the previous simple question, can you see the base fully? It is seen, you have, or from it is seen, base is fully seen. If I tilt this apex, okay, outside to this base, only the base will be hidden. You see how I have tilted? It is not tilted, it is exactly tilted, matching with the base. So can I see the base fully or partially? I can see the base in this orientation, fully the base is visible. If the apex is out of my base, then the base will be partially visible. Now see here, this apex is falling within this base. So I can see the base fully in this simple position. So in this orientation, simple orientation, while looking from the top, I can see the base. Right, all the slant edges are also visible. Now in this orientation, tilted orientation, so also I can see all the base. If you look at in this orientation, you see this, you are looking at in the top view. You are looking at in the top view. See it is like this. Are you seeing the base fully? You can see the base fully. Right, this slant face, triangular slant face will coincide with the one of the base edge. Right, so I can see the base fully. So it is a straight point. If the apex is tilted more than the base, outside the base, then the base will be partially visible. If the apex is tilted within the base is fully visible. Right. So now the base is a fully visible base. So and the boundary as per the hint what I have given in the last class. First of all, you close the boundary of the final view. So this is my boundary. So this boundary is fully visible. This is going to be my boundary. This boundary is fully visible. It's nothing but a base. Right. Now this apex I have. So what about the slant edges? Slant edges, is it visible or? In this condition, how all the slant edges are shown. Similarly, from all the corners, from B to O, the slant edge is visible. From A to O, the slant edge is visible. From F to O, the slant edge is visible. From C to O, the slant edge is visible. It is coinciding on the base itself. From D to O, the slant edge is visible. It is coinciding on the base edge itself. Now, is it clear? Look at the final view. You are concerned about the triangular slant face. The triangular slant face CDO, it is in the top view and the front view, it is seen as a line. That triangular slant face is tilted in such that it is perpendicular to both HP and VP. The CDO is the triangular slant face, has to be seen as a line in the front view, and the CDO should be seen as a line in the top view also. You see, the CDO is a triangular face, it is seen as a line. CDO is a triangular face, it is seen as a line in the front view. Right, this is the orientation. The axis inclination is to HP, it is hidden, that you have to find it out, and you have to draw the base on HP. Is it clear? Do you have any clarification in this? Right, do it. Okay, listen, in your problem, the same kind of problem, you have another problem. Can be possible to give. You see here, listen all of you, listen. In this problem, a triangular slant face is perpendicular to both HP and VP. Right. So another problem can be, instead of triangular slant face, I am interested about this slant edge. If a slant edge is perpendicular to HP and parallel to VP, how it will be? If a slant edge of a pyramid is perpendicular to HP and parallel to VP, then this is the orientation, isn't it? It is resting with a corner. The problem will be given like this. The triangular hexagonal pyramid is resting with one of its base corner such that a slant edge containing the resting corner is vertical. It will be given. It is vertical. Instead of giving it is parallel to VP, it is vertical. Vertical means it should be vertical and it should be parallel. Okay. If it is vertical, then this is the orientation. Then the problem is same. How I have to draw the true shape of the base? I have to draw it in such a way that the corners has to be in the extreme. It is resting with a base corner. The problem is resting with a base corner. I have to redraw like this. Then what I will have in my front view? Yes, slant edge alone I will have. Instead of a triangular face, I will have a slant edge alone in my front view. That slant edge you have to treat it vertical. Then you have to get the final top view. The problem is a different problem, right? Either a triangular slant face is perpendicular to both HP and VP, or a slant edge is vertical. So two problems is possible. Is it clear? If the problem is given, instead of a triangular slant face, a triangular slant edge can be given. Right? problem, you take a problem here. Hexagonal pyramid, same thing. Hexagonal pyramid, same base side, 30 mm and height 70 mm. Resting 70 mm. Listen, is lying on the ground. See here, it's lying on the ground. Not resting, it is lying on the ground with one of its triangular slant face. This is the thing, how it is lying with one of its triangular slant face. A slant face with its triangular slant face is lying like this. So it can be like this. So another specific orientation I have to give. What is that? It is lying on the ground with one of its triangular slant face such that the axis is parallel to VP. Axis is parallel to VP. So axis is parallel to VP, and what about the axis to incline to HP? Axis is like this. How it is to HP? It is inclined. The axis inclination is hidden in this problem also. In this problem also, the axis is inclined to HP. So, what is the problem? It is lying on the ground with one of its triangular slant face in such a way that the axis is parallel to VP. Right? Full stop. Draw the front view and top view of the pyramid. Draw the front view and top view of the pyramid. Lying with one of its triangular slant face. Triangular slant face. Right. So the hidden data here is axis is inclined to HP. So hidden data is axis is inclined to HP. One more hidden data is that you see here, this is a hexagonal pyramid, right? In which orientation I have to draw the cruise shape? You know, the axis is inclined to HP here. So I can draw my base, cruise shape of the base on HP, right? In which orientation I have to draw it? Corner, on corner. Which orientation I have to draw? You see the previous problem, it is resting with an edge. It is given. Here, the resting is whether it is edge or corner is given. That also it is hidden. Now you see, in this line orientation, in the base edge, which one is touching the ground? Edge. In a base, the edge is touching the ground. Right. So it is a problem related to the edge on HP. So it is a problem related to resting on edge. Resting on edge. So this is also hidden in there. So you have to draw your pyramid's true shape of the base such that the edge should be on the extreme, similar to this. Similar to this, you redraw this. Okay, then you tilt it to this line orientation. This is the same thing I will have. This, if I make it, so instead of vertically keeping, I can measure CD and I can mark it on the reference line, then you proceed it. Same problem, do it separately. Simple. It is lying with a triangular slant face, and the triangular slant face which I am going to keep it on the ground is nothing but like CDO again. So CDO triangular slant face is seen in the front view as a line. So I can mark CD on the reference line. See here, this is my C dash, D dash. Right. Then measure CDO. So you mark it conveniently, mark it on the reference line. Right. This is my O dash. So CDO has to be marked on the reference line. Then the same way I can redraw it. Okay, from CD to A, what is the distance I can measure it? That I can have get an R. From O to A, what is the distance I can measure it and I can get an R. So using that I can redraw this. I can redraw the final front view. This is my final front view. Right. See here, listen, to finish the final top view, listen. To finish the final top view, so I have got all the base corners in my final top view by projecting the final front view and the previous top view, right? See here, so in this orientation, in my front view, can I see the whole base in my top view? Is it visible or no? No. While looking from the top, as for this condition, you see lying condition, can I see the base fully by looking from the top? You see here, you see this solid, you see this solid, I am looking from the top, I am able to see the base fully. See here, this orientation, the base is fully visible. This is an inclined one, I can see this corner, I can see this corner. This both corners, right? The whole base is visible while looking from the top as for lying orientation, right? So I can join all my base corners as a continuous one. So as per the hint, what you have to do it, listen, as per the hint given to show the visible and hidden detail, what I have to do it first of all, you close the boundary first of all. So the boundary of this AD, DC, then CB, then BO. This I have another boundary and BO. Right. Then I have EO. It's my boundary line. Right. The boundary is over first of all. So the boundary should be visible fully. So the next, as per the next statement, by looking from the top, the base is fully visible for me. The base is fully visible, so I can close my base corner as a visible line. As a visible line. Then, as per the third hint, to join the slant edge or side edges, so it is a fully visible base. Whatever slant edge is crossing the fully visible base is going to be my hidden slant edge. The another statement says whatever slant edge I have below the axis the slant edge is CO and DO. So the same CO and DO, if I join it in my top, it is going to cross the fully visible base. It is going to cross the fully visible base. If I join AO, it is not crossing. If I join FO, it is not crossing. BO, it is not crossing. If I join C and O slant edge, it is going to cross the fully visible base. That should be shown as a visible line, visible slant edge. Otherwise, below the axis, whatever slant edge you have, or nearest to the reference line, whatever slant edge you have, that slant edge or side edge will be a hidden one in your top view. Alright. So anyhow, my CO and DO is going to be hidden. Right. So I have to connect CO and DO as a dotted line. CO and right. So remaining I have two more slant edge. Two slant edge I had already in my boundary. Remaining slant edge is AO. It is going to be a pretty visible slant edge. FO is going to be another fully visible slant edge. Right. You have any clarification in this? Right. to show the hidden details, right? Follow the hint. Okay, so any problem you can show clearly. So it's similar to the second problem what we have seen. Instead of pyramid, I am going to give a cone. Okay, we have to draw the front view and top view of the cone in the lying condition. Right. So far you have seen prisms, pyramids. Okay, we haven't used cone. See here, you take the problem here, cone. Cone of base diameter, a cone of diameter 50 mm and height, base diameter 50 mm and height 70 mm, is lying on the ground, with one of its circumference point. It is a base only I will have circumference. It is lying with a circumference point. It is lying on a line, right? Huh? Lying with its one of its slantage. As for cone you have slantage, you have a vertical edge. What is that name? How it is lying? Axis is in the middle of the cone. So it is lying. So as for cones and cylinder, you don't have edges, vertical edges or slantage. Already I have told. You will have only this surface. So on that surface, the surface is generated. So the surface is generated, the solid is generated. Okay, the surface of the cylinder and cone is generated. So I have, so it is generated by infinite base points, right? So it is generated by a triangular line. Okay, so since it is generated, I will have a generator. I can name it as a generator. For cones and cylinders, you don't have vertical edges or slant edges. You have only generators. Since I have in my base, I have infinite points. Okay, forms a circle. So I will have infinite generators around the cone. Okay, up to I will have infinite generators around the cylinder. Okay, I will have only surface, cylindrical surface and slant surface for cone. For cylinder, I will have a cylindrical surface. For cone, I will have a slant surface. So I don't have any distinct slant edges. Instead of that, I will have infinite generators around the cone. So it is lying with one of its generators. Right? It is lying. The cone is lying with one of its generators on the ground, such that how? Such that the axis is parallel to VP. Such that the axis is parallel to VP. Lying with its generator, lying on HP with its generator. So the axis is parallel to VP, it is given. Now you look at the solid. What about the axis of the cone? What about the axis of the cone? It is inclined to HP. So the axis inclination is hidden. Axis is inclined to HP. So it is a HP inclined problem. So where I have to draw my true shape of the base on HP. On HP you draw this circle and you proceed the cone. You divide it. As for circle you divide it into 12. You get the generators, you project it. Okay. Then you make it to a tilt, a lying orientation similar to the second problem, and you get the final top view. Okay, so do it. Cone lying on the ground like this, right? So I have drawn the base on the ground, HP, then I have drawn the front view, right? In a simple orientation, then I have tilted the cone. You see here, while drawing the cone, so you have to mark the generator points, base points, that is called generator base point. Then in the front view, you see, you cannot see as for cone, you cannot see all the 12 generators. You cannot show it in your front view. You should not show it in your front view. Why? It is a generator, it is a surface. Only the extreme generator alone, you should show it in your cone. Similarly, in your cylinder. Right. As for cylinder and cone concerned, the extreme generator alone will be shown in your views, in your front view and top view. Right. Now, what is the extreme generator here? AO and GO. That alone will be visible for me. So, the cone will be seen as a triangle in my front view. Right. So, to draw the view of the base circle, I have divided the base circle into 12 finite divisions. That 12 finite locations, you have to mark it on the base of the front view. So whatever you have in your simple question, whatever 12 points you have, that you have to neatly, you have to transfer it, reproduce it in your final front view. Then my final front view will be a triangle. That alone you should draw. You should not join all the generators and you should not draw it like your pyramid. Is it clear? Pyramid, I have finite slant edges. I don't have a slant edge here. I have a generator. That generator is nothing but my surface. I can see only the extreme generator. That to a triangle. Right. So other generators you should not darken it. Right. And you should not show it. Then by projecting all my generators, you see here in the front view which generator is lying on the ground. It is nothing but GO. Okay. GO. The base point which is resting is G. So the generator along that is GO. I have measured that GO and I have marked on the reference line. Then I have reproduced the front view, previous front view, and I have marked all the base point on the appropriate location. Right. Then I have projected from the final front view and I have extended projectors from the previous top view, and I have got all my base circle point, circumference point in my top view as well as the apex in my top view. Now, you look at the front view, can I see the base fully or is it partially visible or fully visible? While looking from the top, the base is fully visible one. So in this orientation, the base is fully visible one. So I can join all my base points as a visible line. Okay. So what is that visible line? Is it a circle or is it an ellipse? It will something like an ellipse. Right. So I have to connect all my base point as a curve. So first of all, use your 2H pencil to try to get a smooth curve. Then finally you darken it. You see here, first of all you try to get a smooth curve using your 2H pencil. So now in my top view, whichever portion in my top view I can see the extreme generator also. What is the extreme generator here in the top view? JO and DO. Right. It is not JO and DO. It need not JO and DO. So whatever point, it exactly won't. Listen all of you, listen. So this circle, you see this circle, ellipse in my top view, you see here, I have a point here in the extreme. What is that? J and D. That has to be joined to my apex. Right. Listen all of you. Listen carefully. If you join this DO, you should not join this generator. If I join this D2O, you see, D2O, how it is going? It is going inside to my base. Right. Similarly, JO, if I join it, it is going inside to my base. This is a wrong one. How I have to show it in my top view? The slant surface, okay, the edge of the surface will be tangently meeting this circle. So you should not join it to the corner, base corner. Whatever ellipse you have drawn, tangent to that, you connect it to the apex. Tangent to that, you connect it to the apex. See here, and tangently I have to connect it to the apex. So this way I have to tangently connect it to my apex. From this circle, wherever it meets tangently, that is a location, the tangent line has to meet it. Right? So it is, you should not join from the corner, the base ellipse, the line, whatever the extreme line, slant line, that should be tangentially meet the. What it means, it is not the generator D is shown in the extreme in my top view. Some other point in my base circle, some other generator will be seen in my top view as an extreme generator. Not exactly what we have divided the finite wall division. Right. So the other one, whatever generator comes in the extreme in my top view, that has to be shown as a visible line. So that is a tangent line which meet the ellipse. Right. Now you can darken this. Finally you can darken this. The cone will be seen in my top view. Is it clear? You have any clarification in this cone problem? Pentagonal pyramid. Pentagonal pyramid. Of side, base side 30 mm and axis height 30 mm. Axis height 30 mm is freely suspended by a string. Is freely suspended by a string from one of its base corners. Freely suspended of its base corners base corner such that the axis of the pyramid is parallel to VP, such that the axis of the pyramid is parallel to VP. Right. So full stop. Draw the projections of the pyramid. Draw the projections of the pyramid. Draw the projections of the pyramid. Right. See here, I have a pyramid. Okay. Pyramid. The problem is like this. The pyramid is suspended, freely suspended by a string from one of its base corner, and it is suspended like this. You see, instead of pentagon, I have a hexagon here. You see. It is suspended with a string from one of its base corner. So it is hanging like this. So it can hang in any orientation. Okay, what is given in your problem condition? It is hanging like this and the axis is parallel to VP. So what I can do it? So I can keep this. I am going to hold this such that the axis is parallel. So such that it is hanging and the axis is parallel to VP. Look at the axis, it is parallel to VP. At the same time, the axis is inclined to which plane? HP. At the same time, as for this hanging problem, the axis is inclined to HP. If it is freely suspended like this, the axis will be inclined to HP. Right, is it? Okay. So again, it is an axis inclined to HP problem. You look at this solid, how it is hanging. So in what orientation it is hanging, that is very important in this one. So any solid, if I hang it like this, okay, the tide point and the center of gravity of the solid, okay, centroid of the solid, okay, center of gravity of the solid. If I connect it with an imaginary line, if I have the tide location and the center of CG of the solid, if I have an imaginary line joining with the connected corner, okay, tide corner and the CG, it will be vertical. It will be vertical. There will be a CG for this pyramid, okay. that CG, if I connect it with the tied base corner with an imaginary line, that imaginary line will be vertical. That imaginary line will be vertical while it is hanging. Okay, that is the thing you should know. Have any clarification on that? Right. So this is how it is going to happen. So make a note. Make a note for this problem. Axis inclined to HP problem. Axis. This is a hidden data you have got. Inclined to HP. Axis inclined to HP. Right. So where I have to draw my base of the pyramid on HP. Right. Axis inclined to HP means you have to draw it on HP. That is below the reference line. You have to draw the base and you have to proceed for the front view. Simple question. Okay. How I have to draw the Pentagon. The Pentagon, you know, you will have only one orientation as possible. If it is hexagon, how I have to draw it? Such that to the extremes, I should keep my what? Corner. Okay, it is tied with a corner. So you see here, it is tied with a suspended with a base corner. So it is something like this thing with a base corner problem. So I should. As for hexagon, corner should come to the extreme. So as for pentagon, you have only one orientation. Okay. Right, is it clear? Any clarification in this again. Right, now coming to this CG. So have another note. The solid will, the imaginary line connecting suspended corner and the CG, center of gravity of the solid is vertical. So solid will be vertical. It will be hanging like this. It will be vertical in the sense what? It is perpendicular to. So that imaginary line connecting the suspended corner and the CG of the solid will be perpendicular to HP. It will be parallel to V. Right. So this is the condition you should remember. Right. Then you make a note for CG, center of gravity. Center of gravity. Okay. For pyramids, where I will have my center of gravity for pyramid. So I will have my pyramid, suppose pyramid or cone. Okay, pyramid or cone. For pyramid or cone, I will have my center of gravity. So I know this solid height. The center of gravity always will be to the middle, okay, on the axis of the solid, right? But exactly for pyramids and as for pyramids and cones, suppose I have the height. Have the height of the pyramid or cone H. So the CG will be exactly on the axis. Okay. From the base, it will have the location of h by 4 distance. H by 4 distance. Right. That is height by 4. So I can say it is the center of gravity will be for the pyramid or cone. It will be from the base. It will be 1 by 4 from the to its height. Right. So for pyramid or cone, CG will be 1 by 4 of height of the solid from base. We should not take 1 by 4 height from apex. Right. From base the CG will be that. So if it is a prism or cylinder, where I will have my center of gravity, it is a perfect prism or cylinder where I will have a center of CG of the solid. It will be exactly in the middle. So it will be exactly in the middle. As for prisms or cylinder, so on the axis, the CG will be exactly in the middle. Right. So I can say 1 by 2 of its height, 1 by 2 of its height, and on the axis. The CG will be on the axis, and 1 by 2 of the solid's height as for prisms and cone. Right. If the CG is 1 by 4 distance of its height of the solid from its base as for cones and pyramid. Right. So we have to mark the CG. What I am telling, suppose this is a suspended corner, base corner, there will be an imaginary line joining the suspended corner and the CG. Okay, that imaginary line while hanging, it will be vertical. This imaginary line, okay, joining the CG of the solid and the suspended corner will be vertical. Okay, will be vertical while you have to redraw this. So the front view will be like this. How I have to draw it? CG, the suspended corner is this. CG, that's what this. You have to measure this length and you have to draw a vertical line. Then you have to redraw the pyramid like this. Is it clear? Then you can go for the final top view. Right. So you proceed to start drawing your true shape of the base of the pentagon on HP. Then you mark the CG in the front view, simple position. Okay, proceed for the tilted orientation, suspended orientation, then get the final top view. Listen, see here, this is the one problem, its axis inclined to HP, right, hanging problem, so I have drawn the base on HP, right, such that a corner should be on the extreme, right, pentagonal base, true shape of the base is drawn such that a corner should be on the extreme. So as for pentagon, I will have a corner and this extreme, right, here, the suspended corner, which is my suspended corner here? C is my suspended corner, right, so as I told, as for this suspended problem, there you have to mark the CG, center of gravity of the solid. So as for pyramids and cones, the CG will be h by 4 this of its height from the base. So the overall height is 70. 70 by 4 is 17.5. So 17.5 from the base, 17.5 from the base. I have to mark the CG on the axis. I have to mark the CG on the axis. See, this is my center of gravity of the solid on the axis. And it is 17.5 distance from the base. So here, now this, if I connect this CG and the suspended corner C, okay, the CG and the suspended corner C, with an imaginary line, right? With an imaginary line CG, C. So that is going to be and vertical. This is going to be vertical in my hanging position, right? Hanging orientation, right? Suspended position. So what I have to do to redraw this front view, how I have to redraw it is then how I have to redraw this to show the final front view. Listen, this CG, such that this CG you measure it. CG to C, suspended corner. What is the distance? You measure it in your compass. Right. You measure it in your compass. That to keep it vertical. That to keep it vertical. Okay. So what I am doing to the top to draw it. Okay. Need a space for from the top to draw it. Okay. This is my C, suspended corner C. This is my CG. Right. So you have to measure it in your front view, that distance. Okay. That to show it as a vertical one. Right. Now it is not a view. Then from these two destinations, can I redraw this, reproduce the front view? It is possible, right? I know two destination locations, right? From these two destination locations, I can get my apex, I can get my C already is there, I can get my A. So I can finally get the triangle. Right. I know C and CG and C. So from CG, what is A distance? From C, what is A distance? You can measure it in your front view, right? That you can reproduce it. Okay, here from CG, what is A distance? That I have to measure it from CG. What is A? Right? From C, what is the distance? From C to A, what is the distance? From C to A. So whatever distance. This is nothing but my A B. This is my A B. A dash B dash. Right. Right. Similarly, I can get my apex from the previous. What is the distance from CG to apex? What is the distance from CG to apex? I can that is from C to apex. What is the distance that I can measure? Otherwise, along the CG is going to be my axis. Along all the CG is perpendicular to this base. My axis is going to be there. On this axis, I have to get my apex. Right. So here, just redrawing. You want two destination location, just reproduce the front view. Right. So now the height either directly or this is the location. Either by intersection I can assign this as apex, or by drawing an axis from this base I can measure the height. Okay, anything you can proceed. Then I can reproduce, redraw this front view like this. This is going to be my front view. What else I have to show? Another more is that I have to show. What is the type? BD. Okay. From C I can measure that BD distance. That I can mark it. That is B dash, B dash. That also I can show it in your front view. Right, this is how I have got my final front view. Right, then you can proceed for your final top view. Proceed. Okay, listen. I have projected my final front view and the previous top view. Okay, I extended projectors. Okay, I got the intersection points of various corners and as well as the apex. Right. Now you have to show the visible and hidden edges. As per the note, what I have to finish it first of all, the boundary. The boundary is you have to join it as a visible line. See here, the boundary here is A to E. A to E is the boundary. A B is the boundary. Then B O. Then E D. So this is the boundary I have joined. Then as for this base, look at the base. Listen. Look at the base. From the top, if I look at the base is fully visible or partially visible. The base is fully visible or partially visible. It is fully visible. So I can connect the base corner as a visible. I can show my base corner as a visible edges in my top view. Right, final top view. The other base is on the periphery boundary itself. Now listen. As per the other note, the side edge or slant edge which is going into the fully visible base, that is going to be hidden. So otherwise, which is the lowest base edge? slant edge or side edge, or below the axis, what all the slant edge or side edge you have, that will be hidden anywhere. Below the axis or lowest slant edge or side edge, which one is? AO and EO. So that is going to be hidden. Similarly, in the top you look at AO, if I draw it, that is going crossing the fully visible base. EO is going to cross the fully visible base. So I can join this, suppose I have to show this slant edge as a dotted hidden slant edge. Right, similarly EO is a hidden slant edge. Right, so the remaining one more slant edge I have, what is that? CO. So CO, it will be visible one, fully visible one. Not each other, fully visible one. Okay, this is how that it is suspended by the string and such that the axis is parallel to VP and the apex is touching the ground. Apex is touching the ground means what I have to do in my this one. So this O has to exactly touch the reference line. How I can draw it? While drawing like this, it will be difficult. As it is, you can draw it. What I can do it in an easy manner. Just I can do this reference line. I can put it here. So in the second step, just this reference line I can show it here. Then I can proceed it. Nothing wrong in that. Okay, this reference line as it is, you can keep it. You can terminate the reference line. This reference line you put it here. Then show the final top view. Is it clear? Another variety, you take another problem, you take it as a homework. A square prism of base side 40 mm and height 60 mm. A square prism of base side 40 mm and height 60 mm is freely suspended by a string. Is freely suspended by a string from one of its base corner. The square prism of base side 40 mm freely suspended by a string from one of its base corners, such a way that the axis is parallel to VP. Again, it is a freely suspended problem. By string, such that the axis is parallel to VP. So draw the projections of the prism. So freely suspended problem, it comes into the category of axis inclined to HP. Right, axis inclined to HP. See here, how I have noted it in your notebook, you do it as your homework, right? Same thing, instead of pyramid, I have a prism. See here, I have a prism. So it is suspended with its base corner. So the base where I have to draw. Since the axis is inclined to HP, I have to draw the base on HP. So the base I can draw it like this. Okay, which one is right? Which orientation is right one? Second. It is suspend. Second one, because the corner is on the extreme. Right. The second one I can draw it. Okay, the base I am going to draw it on HP. So this is the orientation. I have to draw my prism. That is equally inclined orientation. I have to draw my prism. You see here, another base is coinciding here. Right. By just projecting this, I will have my front view. Like this. So the height of the prism, it's 60. prism is 60. So this is how we will have the front view of the prism. Right. So this is my right. Similarly, I will have one. See here. So axis is in the middle. So where I have to mark the CG. CG for prisms, it will be exactly in the middle. So the size is, this is 40, this is 40, and this height is 60. This right. So exactly in the middle, 30. So I have to mark my CG. So CG will be in the middle. So which is the suspended corner here? Again C. So C to CG is going to be suspended like this. Okay, the imaginary line joining CG to C. So that length you have to measure it. That you have to draw it like this. C to CG. Right. Then I have to reproduce the view. This is my C. This CG. I can close my rectangle. This is how you will have your final front view. Look at this. This is C. Right. So you see here, this CGC line and the other corner corresponding bottom one will be in a vertical line. So that is, you should say here. So you have again this is 1, 2, 3, 4. So as for to show the visible and hidden edges, what I have to do is, first of all, the periphery, the boundary I have to connect it with a visible line. So you see A to boundaries of the view should be connected with a visible, shown as a visible line. Right. So what about this base? In this both base, which base is visible for me while looking from the top? The top base ABCD is visible for me. So ABCD is fully visible. So ABCD rotation, I can join it. ABCD base, I can join it with a continuous, show it with a as a visible edge. Then this base is partially visible, that is 2, 3, 4 will be visible, 2, 4, 1 will be hidden. That is 2, 3, 4, it is on the periphery, already it is visible. The remaining half, 2 edges is hidden. Right. The other base, corresponding other base will be a partially visible one, as per the note. Now, as for the side edges concerned, you know, which is the bottommost side edge here? A1. A1 is going to be hidden. Where I have A to 1, A and 1. So that is going to be hidden. Right. Or a side edge which is crossing the fully visible base. Right. So remaining side edge is going to be a visible one. So already I have B2 is visible, D4 is visible, and one more thing is C3. C3 will be visible. So C I have here, C3 will be a visible one. So this is how your top view would be. Right. For this you have to carefully follow your note to show the visible and hidden details. Right. Do this as a homework. Now, it is perpendicular to VP and parallel to HP. Right. Now this orientation it is inclined to VP and parallel to HP. Right. So that is the orientation I am going to give. Take a problem, a cylinder. Cylinder of diameter 50 mm. Height 70 mm. Is lying on the ground. Is lying on the ground. Lying on ground. Ground is nothing but my HP. It is lying on the ground with one of its generators in such a way that with one of its generators, as for cylinder and cone, you will have generators, not vertical edge or slant edge. We will have generators, infinite generators, right? So it is lying on the ground with one of its generators such that the axis is 30-degree inclined. Axis inclined 30-degree to VP. Axis is inclined 30-degree to VP. So no need to give that the axis is parallel to HP, right? Problem is, so if it is lying on the ground, it is a cylinder, no need to give, definitely the axis is going to parallel to HP, right? So draw the projections of the cylinder. Draw the projections of the cylinder. So look at this one, see here, this is a cylinder, listen, cylinder, where the axis is inclined here? Axis is inclined to VP. Where I have to draw the base of the cylinder? VP. Okay, inclined to HP means on HP you will be drawing the base. So far everything you have drawn on HP. So inclined to VP. So axis is inclined to VP. You have to draw the base on VP. So axis is inclined to VP is like this. You see here, the axis is inclined to VP. The cylinder, and it is parallel to VP. The inclination is 30-degree. So I cannot draw it as it is. What I have to do is assuming that just I will be making it the axis perpendicular to VP. So if the axis is perpendicular to VP, I can show the base on VP. That is on front view, right? So you can show the circle on front view, and that to exactly where the circle you have to show it. It is lying on what? It is lying on the ground. So where it will show my circle exactly? It will be touching the reference line. Show the circle, draw the circle, divide it into 12 divisions. You get the top view. So the top view tilt it to 30-degree, redraw it, then get the final front view. So you don't need to show all the generators. Just you divide the circle base alone into 12 finite circumference points. Right? Is it clear? The problem is clear. Just you have to draw the circle touching the reference line above the reference line, that is on VP, since the axis is inclined to VP. Right? So then you proceed for the top view, tilt the top view to 30-degree orientation, get the front view. axis is inclined and it is lying on the ground. I have drawn the true shape of the circle on VP. The axis is inclined to VP on VP. At the same time, the axis is touching the reference line. Right? The axis is touching the reference line since it is lying on the ground. So how I can draw the circle? If the circle you can draw it, then you can draw the reference line touching the circle. Then you can proceed for the simple top view. Okay, top view you can know. Then all the generate circle, how you have divided into 12 segments, and all the segments of both the bases have to be marked in the top view carefully, right? So and the hidden circumference point, base circumference point also should be marked with bracket. Then this top view, okay, this top view is 35 degrees. See here, so I haven't shown the generators, okay, in the top view also. So the generator you have to project it for the, to mark the base corners, called base corners. You should not show the generators, okay, generators should not be visible one. Only the X-line generator should be visible, okay, as per any view for cylinder and cone. Only you can show only the X-line generator. Cylinder can be seen as a rectangle alone in the top view. Right? So the rectangle alone you have to show it, then the axis you have to show it, then the hidden corners you have to mark it. Now what I am going to do, just this top view, simple position top view, just I am going to tilt it to 30 degrees, that is axis is inclined to 35 degrees. So you can draw an axis to 35 degree inclination from the reference line, below the reference line, that is the axis inclined to VP 35 degrees. Then I have redrawn this. Then the axis I have drawn it. Then what I can do, I can measure the base, that is nothing but the one base, that is nothing but 50 mm. Okay, that 50 mm perpendicularly I can draw it. Okay, 25 perpendicularly draw it. Then I can finish off this rectangle in an inclined manner. The same rectangle I have drawn to show the final top view. Final top view. Now, in this final top view, you have to carefully mark all the base points, circumference point, similar to the previous top view what you have got. Okay, that locations carefully you measure it, okay, and you mark it in the final top view also. Then that notations carefully you give it. You don't use the notation top because you have to project the corners to get the final front view. So you show the notations inside the cylinder for the top base, show the notation below the cylinder for the bottom base, so that while projecting it doesn't interfere with projectors, right? So then I can project it to get the final front view. So from the final top view, all two base corners point will be projected to the final front view. Similarly, from the previous front view, I have got drawn the horizontal projectors to get the final front view base corner, final front view base corner for both the bases. So wherever the projector intersects that corners I have marked, okay, in the sequence I will get 2, 3 base and ABCD base, right? Then I can smoothly join the two bases. Okay, now to finish, to show the hidden and visible edges here, okay, you don't have edges, so visible and hidden bases. So you look at the top view from the bottom. So which base is fully visible for you while looking from the bottom? Which base is fully visible for you? Number base or letter base? Number base. Okay. See here, it is like this. Looking from the bottom. Okay. It is like this. It is inclined to VP. For you, which one is visible? The number base is visible. That is the nearest one. That is visible for you. So the number base is visible while looking from the bottom. That base point, I have to join it as a continuous one. Right. Similarly, the other base, number base, so letter base. So this letter base will be partially visible. So up to the axis half will be visible. Above the axis half will be hidden for this. Okay. Up to the axis half is nothing but A, B, N, C, K, D, J. So this half is visible. The other half is hidden. So as per the note, what you can do is conveniently show the periphery of the boundary of the view. Any view will be visible for you. So what is the boundary here? First of all, by joining with a smooth curve. So this is going to be my boundary is fully visible, and you know which base is going to be fully visible is number base. So that number base 1, I can show it as a fully visible one. So try to draw it in 2D pencil first of all. Get a smooth curve. Otherwise erase it and get it as smooth one. Right. So this number base will be fully visible for me. The other one, other base. So the periphery half will be a visible one. The other half will be a hidden one. So that portion I can show it as a hidden curve. Right. So this is how we have to show. So only you can see in this front view, the extreme generator of the cylinder will be shown as a dark one. That is nothing but the boundary of the cylinder will be shown as a continuous one. Inner I have one generator that should not be shown as a visible one. Right. So the projector lines will be shown. Okay, that is in light to which pencil. Okay, the base corner. So as far cylinder and cone concerned, only the extreme generator will be shown in your view. Right. The points will be, to get the base point, we will be marking and we will be using the projectors. Okay, extending the projectors to get the base point. Right, is it clear? Do you have any clarification in this? So the square pyramid, the square pyramid. The square pyramid. Square pyramid of base side 40 mm and height 70 mm. 40 mm and 70 mm is resting on HP with one of its base corner. Resting on HP with one of its base corner. So resting on a corner. Resting on a corner on HP. Resting on a corner on HP on the ground. With a base edge adjacent to the resting corner. With the base edge adjacent to the resting corner is, see here, it is a square pyramid I have, okay, square and pyramid. It is resting on HP like this. So with the base corner, a corner is resting on HP. The corner is resting on HP like this. And a base edge, and the base edge, I have 4 base edges, and a base edge adjacent to the resting corner. For a resting corner, I have 2 adjacent edges, base edges, right? So, for adjacent to the resting corner is 20° inclined to HP. Base edge adjacent to the resting corner is 20° inclined to HP. So, what it is? Yeah, edge. Okay, adjacent to the resting corner will be 20° inclined. So, in this orientation, it is equally inclined, 45°. So, one of the edge I am inclining it as 20°. So this is about the base edge and the resting orientation. Then to draw the projections of the solid. Draw the projections of the solid. If the axis, now how the axis as per this orientation, what I have to care. Now this orientation is perpendicular to it, I can draw the shape here, right? So draw the projection. If the axis is 45 degrees, the axis is 45 degrees like this, inclined to 45° inclined to VP, and at the same time how it is to HP, axis is parallel to HP. The axis is 45° inclined to VP, and at the same time it is parallel to HP. So this is the orientation. For this you have to draw the true shape, and so for this you have to draw the front view and top view. So in an easy manner, okay, without understanding what I have to, where I have to draw the base straight away. VP, axis is inclined to VP. Straight away I can draw the base on VP. So VP, while drawing the base square on VP, how I have to draw it? That orientation is given. So a corner should touch the reference line. A corner should touch the reference line. So from that corner, the square sides will be, while constructing the square side, one of the sides should be 20-degree inclined to HP. See here, so this is the inclined orientation. Just I will be tilting, assuming that the axis inclination, making it perpendicular to VP. Okay, making it perpendicular to VP, and a corner is resting on HP, and an adjacent side is 20-degree inclined to HP. Okay, this way I have to draw the true shape. So this way I have to draw the true shape. So this is the perpendicular one. See here. So it is resting on HP like this. I am showing it here. It is resting on HP like this with a corner. Right. So once it is resting like this, it is equally inclined. I have two edges. Right. I have two edges adjacent to that. One of the edges, how it is inclined? 20-degree inclined. Okay, one of adjacent side, adjacent base edge to the resting corner is 20 degrees. So I can draw a 20-degree line. Draw a 20-degree line along that will be like this. Right. So one side is 20 degrees. Either it can be left side or right side. Okay. So this right side. Okay. So this is a 20-degree orientation. So I can mark a corner here. I can draw a square in my VP front view. So then you can. At a corner edge adjacent to the resting corner is 20 degree. So I have drawn the true shape of the square pyramid on VP like this. Then I have projected for the simple position top view. Right, the top view will be like this. So carefully you have to show the slant edges. You see, look at this. So while looking from the top, A, O and BO and CO will be visible. So corner B is hidden for me. So in my top view, B is hidden, and BO slant edge also it will be hidden. So you should show that as a dotted line. Right. So this is my simple top view. Right. Then this I have to reproduce it in a 45-degree inclined manner. Just draw a 45-degree axis line. Then you reproduce the image and draw a perpendicular base to that. Then you reproduce the final top view. This is going to be the final top view, the same one. Then you project all the final top view points, corners to the front view, final front view to get the final front view. Similarly, from the previous front view, you draw horizontal projector. The intersection will give me the front view points, final front view points. You mark it carefully. So then as per the note, as per the note, we have to, as per the note, first of all, you listen all of you, listen, as per the note, first of all you have to show the boundary as a visible one. You see the boundary AB and BOB. Right, that is going to be of this my front view. This is my boundary of my final front view. Then after that, as per the second note, you look at the top view. While looking from the bottom, the top view, is this the base is fully visible or partially visible? The base is not visible for me. Okay, the base is not visible for me. I can see some of the edges and some of the edges are hidden. That is, above the axis is hidden, below the axis is visible. So in this orientation, base is not visible, you see. So it is tilted like this. Can you see the base? is not visible. It is not visible. So some of the edges of the base are visible. So it is a partially visible base. So the periphery, as per the periphery, I have visible edges of that base. The remaining portion is hidden for me. So I have to show the base as a partially visible base. So remaining side edge, remaining base edges will be visible. That is
so C should be below. C dash.
C dash. Sorry. C is here. Same mistake I have done. The C is here. This is my C dash. So C to D base edge is hidden for me. Then similarly B to C base edge is hidden for me. Now this is a partially visible base. So there is no fully visible base. It is a partially visible base. I have two more side edges. Already I have B2O side slant edge is drawn. It is a visible. It is on the boundary. DO it's a slant edge. It is on the boundary. It is visible. What about AO? Is it visible slant edge? What about CO? Is it visible or hidden slant edge? How I can find it out? Look at the top view. Look at the top view, which is the nearest slant edge to the reference line. CO. So that CO slant edge, which is nearer to the reference line, that is going to be my hidden one. So that is going to be, so CO, while joining CO will be a hidden one. That's slant edge. Similarly, same note you can check it. So the corner C is going to be a hidden corner while looking from the bottom. While looking from the bottom, fully hidden corner is nothing but my C. So that's fully hidden corner. I can identify it with a corner which is of two dotted base edge, hidden base edge. The corner which is of two hidden base edge. So this is a corner C. It is of hidden base edge and it is of hidden base edge BC. It is an intersection point of two hidden base edges. So this is a corner is going to be a fully hidden corner. From that corner, if I join to any, if I draw any slant edge or side edge, that is going to be hidden. So that is another note, right? So anything if you read it, the same thing will be a hidden slant edge. So C2O is a hidden slant edge. Right. But A2O will be a visible one. This is visible from here, from the bottom. AO is a fully visible one, visible slant edge. So this is how your final front view. Right. So clear, carefully you show the visible and hidden details. Sorry, again I have made a mistake here. Listen. What we have made here, again I have made a mistake. I have to mark A here. Right. Right. I have to mark A here. This is my B dash. A2. So this is going to be my periphery. Right. Then my A2O. This is how my final top view, front view will be. Right. Side 40 mm and height 70 mm is touching VP, is touching, or it is in VP, it is in VP, it is in VP, it is in VP with one of its slant edge, with one of its in VP with a slant edge, slant edge. So how it is in VP with a slant edge. So it is my VP. Okay. It is in VP with a slant edge this. So I have a slant edge. Okay, that slant edge, for slant edge I have one of the slant edges on VP. So it is in VP. So what about the axis here? Axis inclined to which plane? Axis. So axis, you know, for pyramid it is from the middle to the apex. Okay. So how many axis inclined to? Inclined to VP. So axis is inclined to VP. Axis inclination condition is hidden here. You see here, the axis is like this. Axis I have here from the center, it is going to the board. So it is going to be like this. So the axis is going to be inclined to VP. There is a condition, axis is inclined to VP. That condition is hidden here. Directly the axis inclination is not given. Depends upon the size of the solid, okay, specification of the solid, axis will be inclined. Right. So at the same time, it can be inclined like this. It can be like this. So I have to give one more condition. What is that? Axis is such that the axis is parallel to HP. Okay. If it is the orientation, the axis is parallel to. Suppose if this is the orientation, the axis is inclined to both the plane. So I told in your syllabus you don't have the both inclination. So the axis is inclined only to VP and it is parallel to HP. So it is in VP with a slant edge such that the axis of the pyramid is parallel to HP. Parallel to HP. Right. So you see here, it is that as per the explanation, you know, the axis is inclined to what? It is a hidden data given axis inclined to VP. So axis inclined to VP. As per this case, if the solid is lying on VP, then the axis is going to be inclined to VP. The same problem, you know, already in HP inclination we have seen like this. It is lying with what? With a slant edge. With a slant face. With a slant face. Now the axis is inclined to what? Axis is inclined to HP. So here it is lying like this. If it is lying with a slant face like this, again the axis is inclined to VP. So instead of lying with a slant face, I am using it is lying with a slant edge. Right. So slant face, if it is lying on a slant face, that also similarly the axis is inclined to VP problem. So axis is inclined to VP. So where I have to draw the base? On VP. So one more thing, on VP you have to draw it. So on VP. First orientation, is it right? Second one. So you see here whether it is, so in this orientation, suppose if it is in this orientation, so what is touching the base, whether a base edge is touching VP or a base corner is touching VP in this base edge. So for this I have to draw it like this, that is the edge should be on the extreme. So this problem, it is like this. Right, a corner, a slant edge is lying in VP. So if I make it perpendicular like this, it will be like this. So it will be like this. So I have to show the base in an equally inclined manner. Right. So if it is lying like this, it will be a square like this. So a base edge will be resting on VP. Here, if it is lying like this, a base corner will be resting on VP, and so I have to keep my corners in the extreme. So here it is lying with a slant edge. So while it is on VP with a slant edge, so in a base a corner will be on VP. In a base a corner will be on VP. If it is lying with a triangular face on in VP, then in a base the edge will be on VP. Right. So in this orientation, base in a base the edge will be on VP. So in this orientation, the corner will be on VP. Base corner will be. So depending upon your problem, either slant edge or slant face. So here it is a a slant edge, I have to draw it in such a way that in an equally inclined manner, keep my corners in the extreme. Keeping my corners in the extreme. You draw the square like this, you proceed for the simple top view, right? Then you tilt the top view. Okay, while tilting the top view, what I have to do is, first of all, you draw the simple question. See here, which is the resting corner here? So which is the resting, which is going to be, which slant edge is going to be on VP, which slant edge? So if it is like this, CO, so CO is going to be on VP, right? C and O slant edge. So resting corner is going to be C. So C is the resting corner and CO is a slant edge which is going to be on VP. So I can see this as a straight line and I can see this as a straight line. So you measure from the top view, you measure CO distance, where it should be, you have to mark it CO. CO you measure it, where it should be. See, in this orientation, where that CO will fall. CO will fall in the top view, where it will fall. CO. Is the orientation given in the problem. Okay, in the front view will be like this. Top view where the CO edge touching slant edge, where it will fall in the top view. It will fall on the reference line. So CO you measure it, you mark C and O. C and O you measure it and you mark it. CO you measure it and mark it on the reference line. So then you reproduce this final top view here. Then we proceed for the final front view. Great. The final top view, and from the final top view I have drawn vertical projectors from all the corners, and from the previous front view I have drawn horizontal projectors from all the corners. I have got the intersection location, intersection points, that is the front view points, final front view points. Okay, exactly. Then here you see this, as per the note you have to show the boundary first of all as a visible one. My boundaries are from D to C is a boundary, is a visible one, continuously line visible one. From C to D is a boundary, then B to O is my boundary, then D to O my boundary. It will be a visible one. Then as for the base, look at the top view from the bottom. Top view, I can see the whole base. From bottom, if I look at the top view, I can see whole base. So the base is fully visible for me in this one. So the base, I can show it. Base edges, I can show it as a fully visible line. Right. Already I have got two slant. Then as for the slant edges, to show the slant edges, whether it is visible or hidden, you have to find it out. From the top you see, whichever nearer to the reference line, that is nothing but CO, that is above the axis, CO is nearer to the reference line. So that CO slant edge will be a hidden one. Similarly, this is a fully visible base. So if I join CO, that CO slant edge is crossing the fully visible base. That slant edge will be a dotted one. Right. So C to O will be a dotted hidden slant edge. So one more slant edge I have to join it. Okay, all three slant edge I have drawn. B to O, D to O, C to O. Right. Then A to O I have a slant edge. That will be a fully visible one. So overlapping the preceding the hidden detail, I have to show my visible slant edge AO, that portion alone. So this is how my final front view will be. Pentagonal pyramid. of base side 25 mm, 25 mm, and height 70 mm. Is in VP with a base corner is in VP with a base corner such that the slanted, so it is say it is a hexagonal pyramid I have here, so it is a pentagonal pyramid actually the problem, so it is in VP like this with a base corner, right, it is in VP like this such that the slantage containing the base corner, you see the slantage, this is a slantage containing the base corner is perpendicular to VP. Is perpendicular to VP. The slantage containing the base corner is nothing but what? It is a line. It is a line. If it is perpendicular to VP means it has to parallel to HP, right? It is perpendicular to VP. So draw the front view and top view of the pyramid. Draw the front view and top view of the pyramid. Now, how it is? It is like this. So which one is it is? So in this orientation, you see in this orientation, okay, in this orientation, what about the axis of the solid? In this orientation, what about the axis of the solid? How about the axis of the solid? Axis is inclined to HP or VP? Axis is going to be like this. Axis is inclined to VP. Axis is inclined to VP. The hidden data is axis is inclined to VP. And it is resting with a corner or edge. Resting with a corner. That is given. Okay. So, in this orientation, I know the hidden data here is in VP. It is in VP with a corner. And slantage containing that corner is perpendicular to VP, right? And the axis is inclined to what? It is a hidden data, axis inclined to VP. So I have to draw my true shape of the base, pentagon, on VP, right? On VP I have to draw my true shape. See here, on VP I have to draw my true shape. Right. Now you see which is the slantage I am interested about. Which is the slantage I am looking about here in this problem. The slantage is CO. CO is the slantage going to be perpendicular to VP. CO I have. The CO is the slantage is going to be perpendicular to VP. Right. CO is the slantage is going to be perpendicular to VP. So CO is this slantage I am looking about. In the top view I have that CO here. That CO should be, how I have to redraw that CO in my final top view. See, I can mark it on the reference line. See, CO how it should be in the top view. Listen all of you, listen. CO how it should be in the top view. See here. So this is the orientation is given. It is like this. CO how it should be in the top view. C is on the reference line, right? CO will be, should be, I have to redraw this. How I have to redraw that? That CO slantage, okay, CO slantage, how it should be. Okay, I have a line, listen, I have a line that is perpendicular to VP. What about in top view that is? A straight line, okay, a straight line. That line is nothing but CO, okay. A CO line, I have to make it as a straight line, okay, in my final top view. So CO you measure it, draw it as a straight line. CO you measure it, draw it as a straight line. So that is my CO. Then you reproduce this front view. Reproduce this top. See here. See here. The same kind of problem it is given in HP inclination. Okay, instead of that a triangular face is vertical. The HP inclination problem I have given a triangular slant face is vertical. Instead of a slant edge vertical, a triangular slant face is vertical I have given in HP inclination. Right. So similarly a slant edge is perpendicular to VP like this it is given as for VP inclination. So that slant edge which I have interested, that slant edge I have drawn it as a vertical line. Then I have redrawn this. Right. So then you can proceed for your final front view. Right. So whether this base is fully visible or partially visible while looking from the bottom. Base is fully visible or partially visible. It is fully visible. Why? I told the apex it is not out of the base. So if the apex is out of the base is hidden. The apex is inside to the base, falls inside to the base. By looking from the top, you see here. Here I have the, so this pyramid I have. If I look at the pyramid from the top as it is in a perpendicular orientation, I can see the base and all the slanted. Similarly, if the apex is tilted beyond this base, the base will be partially visible. If it is tilted within this base, I can see all the base edges in my view. Alright, the same thing you see, this apex and the base. Base is from A to C I have base. The apex is within this A to C it is falling. It is vertical, so it will fall exactly on C. So I will have O also here. So the base is fully visible as for this condition also. This orientation also. Base, I can show it as a fully visible one. Base, as a fully visible one. As per slant edge, so this is going to be one slant edge because O I have BO slant edge, DO slant edge is O. What about AO, EO? It is a visible one, similar to this. So all the slant edges are visible. If the apex is within the base, all the slant edges are visible. Similarly, here the slant edges are visible. So B to O, A to O, and E to O. So B to O already there, E to O is already there. So all these slant edges are visible. This is going to be my final front view. Is it clear? So instead of this slant edge, a face can be given. A triangular face is vertical, perpendicular to HP and BP. So the same problem may be given. Similar to your HP inclined problem, what we have seen. Instead of a slant edge, a triangular slant face can be perpendicular to VP and perpendicular to HP. The same problem will be given like that. For that, which one you have to consider? Which triangular face you have to consider? AEO. So it is a triangular face. I have to consider. If it is a pentagon, so AE I will be considering it as a resting base edge, and AEO I will consider as a triangular slant face. That triangular slant face I have to make it vertical. AEO is nothing but a triangular slant face. Here what I have, CO, it is nothing but a slant edge. What is this AEO? It is nothing but a triangular slant face. I have three notations. AEO as a line, that is nothing but a triangular face. Okay, triangular face. So that triangular face I have to mark it, I have to make it as a vertical one. If it is slant edge, I have to mark CO. CO is nothing but an edge. That edge I have made it as a vertical one. The same problem is triangular face is vertical in the sense AEO you have to measure it and you have to show it as a vertical one. You have to redraw the top view and you have to proceed for the front view, final front view. Is it clear?